Hello everyone, I am Samir from second year IT department. Today we are going to talk about QR decomposition in Python using Grand Scheme process. First, what is QR? QR is a fundamental matrix factorization method that breaks down a matrix into two simpler forms. First form is orthogonal form. In orthogonal decomposition, matrix factorization, Q matrix and R matrix. In matrix factorization, decomposes any matrices A into product of two special matrices into A, where A equal to Q into R, where Q matrix contain orthonormal basis vectors, where R matrix contain an upper triangular matrix with zeros below the main diagonal. Why QR decomposition matters? In QR decomposition, especially used in linear system solution, least squares problems and eigenvalues algorithm numerically stability. The Gram-Schmidt algorithm functions based on the initialize the first vector, take the first column of a matrix A and normalize into create a Q of formula. Orthogonalize remaining vectors for each subsequent column A, subtract projection onto all previous Q vectors and normalize the result. Form Q matrix, collect all Q vectors into matrix Q, then compute R equal to Q power TA. In using First, we have to make it the breakdown by step. First, we have to do the matrix initialization. Create empty matrices Q and U with proper dimension based on input matrix A. First, vector processing, copy first column and normalize using L2 norm to create the initial normal vector. Orthogonalization loop, and then we have finally R matrix computation. Next, we are going to see about an example, like write the algorithm for QR decomposition using Grand Scheme process. In first process, we have to take the import numpy. First, we have to import a numpy based on the sum, and next we have to define the function using def define QR decomposition A. Next, we have to get the size of the matrix, like gives the rows and column of the matrix. Next, initialize Q and U matrix for the following, and next start the Gram-Schmidt process. We begin first with column of A, we assign it to U and then normalize to get the first column Q. Next, loop for remaining columns. We start the columns of A, subtract the projection of all previous Q vectors, then normalize to get the new orthogonal vector. Next, we have to compute R matrix, R equal to np.0 m, and where we have to give that. Okay, next we have to print Q and R, and we have to get the input and call the function. We take matrix input from the user, convert it into a num array and call our function. It is our example.